When we gaze at the night sky, we're not just looking at distant points of light, we're peering into a vast cosmic ocean, filled with mysteries and possibilities. For thousands of years, humans have wondered what lies beyond our world, letting our imagination soar past the boundaries of our atmosphere. The stars have inspired stories, guided explorers, and sparked a relentless curiosity that drives us to reach further than ever before. Our dreams of leaving Earth have always been tied to our closest celestial neighbors. The Moon and Mars have loomed large in our collective imagination, representing the first stepping stones into the wider universe. They are the most visible, the most accessible, and the most tantalizing targets for our first journeys beyond our home planet. The Moon, a silent companion that has circled Earth for billions of years, is the first world where human boots have left their mark. In 1969, the Apollo 11 mission made history, proving that humanity could break free from Earth's gravity and set foot on another world. The lunar surface, with its powdery regolith and stark shadows, became a symbol of what we could achieve when we dared to dream big. The Moon is a reachable goal, just 3 days away by spacecraft, a cosmic neighbor close enough to visit, yet alien enough to challenge us. Its proximity has made it the perfect testing ground for new technologies, and the first destination for humanity's expansion into space. Mars, the red planet, has captured our imagination for centuries. Its rusty hue and wandering path across the sky have inspired countless myths and scientific inquiries. Unlike the Moon, Mars is a world with seasons, polar ice caps, and the tantalizing possibility that life may have once existed there. The surface of Mars tells a story of a watery past. Ancient riverbeds and deltas hint at a time when liquid water flowed freely, raising hopes that life could have emerged in its distant history. Today, robotic explorers scour its surface, searching for clues about its past and the potential for future human settlement. These two bodies, the Moon and Mars, are logical first steps in humanity's cosmic expansion. They offer unique challenges and opportunities, serving as proving grounds for the skills and technologies we'll need to survive beyond Earth. Astronauts train in simulated habitats, preparing for the day when humans will live and work on these distant worlds. They are the front porch of our solar system, the first destinations on a journey that could one day take us to the stars. By learning to thrive on the Moon and Mars, we take our first tentative steps into a much larger universe. Here, we learn to live beyond Earth, testing our ability to build shelters, grow food, and create new communities in environments far more hostile than anything we've known. Each experiment, each mission brings us closer to becoming a truly spacefaring species. However, as we focus on these nearby worlds, we must also recognize their limitations. The Moon and Mars, while excellent for short-term bases and exploration, may not be the best candidates for a self-sustaining human civilization. Their thin or non-existent atmospheres and lack of a protective magnetic field expose future settlers to dangerous cosmic radiation. Mars and the Moon, while excellent for short-term bases, have a life-threatening flaw: radiation. Without Earth's magnetic shield, both worlds are bombarded by cosmic rays and solar particles, making long-term habitation a daunting challenge. Heavy shielding or underground habitats would be required just to survive. This makes them less of a new home and more of a bunker, places to hide from the dangers of space, rather than thrive in a new world. The dream of building a vibrant, open society on the surface remains out of reach, at least for now. As we plan our next steps, we must look further, beyond the familiar orbits of the inner planets, toward the outer solar system. There, new possibilities await, offering hope for a future where humanity can truly flourish. The answer may lie in the Saturnian system, a realm of majestic rings and mysterious moons. Among them, Titan stands out as a world unlike any other, a place with a thick, protective atmosphere and abundant resources. Titan's dense, nitrogen-rich atmosphere shields its surface from radiation, making it one of the safest places in the solar system for future explorers. Its lakes and rivers of liquid methane and ethane, while alien, offer resources that could be harnessed for energy and life support. Here, the vision of a self-sustaining human colony becomes more than just a dream. It becomes a real possibility. Titan challenges our assumptions about where life can thrive and invites us to dream on a grander scale. As we take our first steps beyond Earth, we must keep our eyes on the horizon, daring to imagine futures even more extraordinary than we once believed possible. The greatest obstacle to a permanent human presence on the Moon or Mars is radiation. Unlike the challenges of building habitats or growing food, radiation is an invisible, relentless threat that never sleeps. It seeps through the thin atmospheres and barren landscapes, bombarding any would-be colonists with high-energy particles from the sun and distant galaxies. This radiation can damage cells, increase cancer risk, and even harm electronic equipment, making long-term survival a daunting prospect. Earth is protected by a magnetic field and atmosphere, deflecting deadly cosmic rays. Our planet's magnetic field acts like a giant shield, wrapping around us and steering away most of the harmful radiation. The thick, multi-layered atmosphere absorbs what little gets through, creating a safe haven where life can thrive. This natural protection is something we often take for granted, but it's the reason why life on Earth has flourished for billions of years. But on the Moon and Mars, there is no such protection. The lunar surface is completely exposed, with no atmosphere or magnetic field to speak of. Mars, while slightly better, still offers little defense. Both worlds are constantly bathed in radiation, making them harsh and unforgiving environments for humans. Mars lost its magnetic field billions of years ago, and its thin atmosphere offers little shield. Over time, the solar wind stripped away most of its air, leaving behind a cold, dry world where cosmic rays rain down almost unimpeded. The Martian sky, once blue and protective, is now a faint, rusty haze that does little to block radiation. Colonists would face severe health risks, with surface activities limited to short, essential tasks. Every moment spent outside would require heavy shielding and careful planning. Prolonged exposure could lead to radiation sickness, genetic mutations, and a host of long-term health problems. The dream of exploring and settling these worlds comes with a heavy price. To survive, settlers would become a civilization of burrowers, living in underground shelters. Thick layers of rock and soil would be their only refuge, blocking out the deadly rays from above. Life would be spent mostly indoors, in artificial environments designed to mimic the comforts of Earth as much as possible. This lifestyle presents psychological challenges, confining humanity to a troglodytic existence. The lack of sunlight, open spaces, and natural scenery could take a toll on mental health, leading to feelings of isolation and claustrophobia. Social bonds would be tested, and the longing for the open sky would be ever present. To find a truly habitable world, we must look beyond, to a place with a substantial atmosphere. Only on a planet with its own protective shield, thick air and a strong magnetic field, can we hope to walk freely on the surface, bask in sunlight, and build a future without fear of the invisible dangers from space. In contrast to Mars and the Moon, Titan offers a unique sanctuary. Its dense, nitrogen-rich atmosphere is thicker than Earth's, providing natural radiation protection. This transforms the dream of surface living into a tangible possibility. Colonists could build habitats and cities on the surface, enjoying an open, expansive life. Titan's atmosphere, combined with Saturn's magnetosphere, makes it one of the safest places from radiation. This protection allows for human activity without severe time constraints, accelerating colony development. Titan's atmosphere offers advantages for human settlement, pressure, and composition. The surface pressure is manageable, allowing for simpler, flexible garments for outdoor activities. Titan's atmosphere is mostly nitrogen, a critical resource for creating a breathable environment. Colonists could use local air, filtering hydrocarbons and adding oxygen, reducing Earth dependence. This simplifies life support systems and makes the colony more resilient. The pressure dynamics simplify construction and safety protocols. A puncture would lead to a manageable leak, not explosive decompression. Titan's atmosphere supports engineering and life support systems for a future human colony. It is an environment almost tailor-made for human habitation. A sustainable colony must use local materials, and Titan is abundant. Its crust is primarily water ice, a vital resource for drinking, agriculture, and sanitation. Electrolysis of water provides oxygen for breathing and hydrogen for fuel. Titan's true treasure is its vast reserves of hydrocarbons, filling its lakes and seas. These hydrocarbons, combined with oxygen, become potent rocket fuel and energy sources. They are also building blocks for polymers, allowing colonists to manufacture materials locally. This reduces dependence on Earth and supports a thriving industrial ecosystem. The nitrogen-rich atmosphere, combined with water and hydrocarbons, supports agriculture. Titan could become the first truly autonomous human settlement beyond Earth. Life on Titan offers a unique experience due to its low gravity and thick atmosphere. Titan's gravity is about 14% of Earth's, making tasks easier. The combination allows for personal, winged flight, a direct consequence of Titan's environment. Colonists could explore the landscape by soaring through the skies. The terminal velocity on Titan is low, making falls safe. This safety feature reduces risks in construction and exploration. Titan's environment shapes its architecture and culture, offering freedom of movement. It invites humanity not just to survive, but to soar. Titan's location within the Saturnian system makes it a strategic outpost. Saturn, with over 140 moons, offers unique exploration opportunities. A base on Titan would serve as a hub for missions to study these worlds. Enceladus, with its water plumes, is a promising target for life exploration. Titan could also be a refueling station for missions to the outer solar system. It would become a hub of science, industry, and exploration. Establishing a presence there opens up an entire region of the solar system. The vision of a civilization on Titan faces colossal challenges. The first obstacle is distance. A trip would take over 7 years with current technology. Establishing a colony requires a revolution in propulsion technology. Titan receives only about 1% of the sunlight, making solar power impractical. A Titan colony would need nuclear energy, initially shipped from Earth. The cost of establishing a colony would be unprecedented, requiring global cooperation. These challenges place Titan colonization in the distant future. It is a long-term prospect, likely attempted after experience on the Moon and Mars. Titan is humanity's long-term destination, a world that beckons us to imagine a future far beyond the boundaries of Earth. Here, we envision not just survival, but the flourishing of a true surface-dwelling civilization, one that could thrive for generations under alien skies. Titan's thick, nitrogen-rich atmosphere provides a natural shield against the harsh radiation that bombards most other worlds. Unlike the airless Moon or the thin, unprotected skies of Mars, Titan's dense clouds offer a protective cocoon, making it one of the safest places in the outer solar system for human life to take root. Beneath this alien sky, Titan's abundant resources, hydrocarbons, water ice, and organic compounds could support a self-sustaining industrial society. Future settlers might harness these materials to build cities, generate energy, and manufacture everything needed for daily life, all without constant resupply from Earth. The unique physics of Titan's environment, with its low gravity and thick atmosphere, promise a quality of life unimaginable elsewhere. Imagine gliding effortlessly across the surface, or soaring above the icy plains, with wings strapped to your arms. On Titan, human flight could become a reality. Of course, the challenges are immense. Colonizing Titan will require new technologies, bold engineering, and the patience of generations. But every blueprint drawn and every experiment run brings us closer to this extraordinary goal, a future where humanity is truly interplanetary. A thriving Titan colony would serve as a strategic hub for exploring the outer solar system. From its surface, we could launch missions to distant moons, study Saturn's mysteries, and push the boundaries of human knowledge even further. By establishing a permanent presence on Titan, we would secure humanity's long-term future, spreading our consciousness and creativity to the farthest reaches of the cosmos. It's a vision that inspires hope and wonder, a testament to our enduring spirit of exploration. As we take our first steps on the Moon and Mars, we should remember that these missions are just the beginning. Each journey outward is a stepping stone, preparing us for the even greater adventure that awaits on Titan. Titan is our future, a dream worth pursuing, a horizon that calls us to reach higher, go farther, and imagine what humanity can become among the stars.